People often use the terms crust and tectonic plates interchangeably. It can be confusing because they're paired, and yet they are distinct from each other. Earth's outermost layers can be defined using two separate properties, mechanical or compositional. First, mechanical. Earth's 100-kilometer thick outermost rigid shell, called the lithosphere, is thin and brittle, analogous in its thickness like an eggshell is relative to the Earth's diameter. Lithosphere is underlain by asthenosphere, the weaker and hotter part of the upper mantle. The lithosphere rides over the asthenosphere as enormous slabs called tectonic or lithospheric plates. If we instead split the Earth's outermost layers by chemical properties, it forces us to split crust apart from the tectonic plate. The silica-rich crust comes in two types: thick continental crust, which is mostly rock like granite and sandstone, and thin, dense oceanic crust that forms at mid-ocean ridges from basalt. The upper mantle is higher in heavy elements, thus is denser. Only the top 100 kilometers of the upper mantle, known as lithospheric mantle, is cool and brittle. The asthenosphere is the same mantle composition, but it's hotter and softer. The brittle crust and lithospheric mantle are grouped as a mechanical unit to form the tectonic plates. The plates can be oceanic or continental, depending on the overlying crust. Still confused? Let's try an analogy. If you put pudding cake batter in a too-hot oven, the upper part cooks too fast and hardens, while the lower pudding part stays soft, even though they're the same composition. Next, add an icing that hardens. The crust and upper cake are different compositions, but can move as a rigid unit over the soft pudding.